Welcome back to another tutorial of 10th class math chapter 2 sets. So first we are going to say about equal sets. So what are equal sets? If two or more sets having exactly same elements present are known as equal set, right? So consider a set A which have elements Sachin, Dravid and Kohli. B, Dravid, Sachin and Dhoni. C, Kohli, Dravid and Sachin. So A has Sachin. Who else has Sachin? B has Sachin. C also has Sachin. Let's look at the next element. A has Dravid. B has Dravid. C has Dravid. Now A has Kohli, but B has Dhoni. It is out. Now C has Kohli, right? A and C has all the elements that are exactly same. In the above sets, all the players A and C are the same, but one player in B is different, right? Because we have Dhoni instead of Kohli. That is, set A and set C are known as equal sets. Two sets A and C are said to be equal if every element of A belongs to C and C belongs to A, right? That is what we have seen. All the elements of A will also be present in all the elements of C, whereas all the elements of C will also be present in the set A. And if they are equal, then we can write A equals to C. Thus we can also write C belongs to A and A belongs to B if and only if A equals to C. This is known as if and only if. Moving on to exercise 2.3. Which of the following sets are equal? Let's see. A is equals to X is a letter in the word follow. We have FOLLOW. Now B. X is a letter in the word flow. FLOW. Next, set C, where X is a letter in the word WOLF. So, what are the elements we have in A? We have F, we have O, we have L, O, W. But we know that a set needs to contain distinct element, right? No element can be repeated. So we will remove this one L. So what are the letters we have? F, L, O, W. Similarly, in B we have F, L, O, W, right? In C we have F, L, O, W in the form of wolf. So all these three sets have same elements. It is an equal set. Now, second question. Consider the following sets and fill up the blanks with equal or not equal. We need to see. We have these questions. We need to read these statements and see which sets are equal and which are not. So, first question we have is A is a set with 1, 2, 3 and B is a set the first three natural numbers. So, the first question is A and B. Are those two equal? Yes. This is first three natural numbers, right? The first three natural numbers are 1, 2, 3. So A equals to B. So we will write equal here. Now, second is A equal to C. A equals to E. What's E? A, E, I, O, U. No, these are vowels and these are natural numbers. So it's not equal. The third one. What about C and D? C is A, B, C, D. And D, what about D? D is D, C, B, A. The elements are same. We have A. We have B, we have B. We have C, we have C. We have D, we have D. So, yes. Third is also equal. Now, fourth one. D and F. What's D? D, C, B, A. Sets of vowel in English. No, these are not vowels. So, it is also not equal. Now, next. F and A. Sets of vowel are 1 to 3. What's A? 1 to 3, right? 1 to 3 and sets of vowel are the same. No, they are not. So, it is also not equal. D and E. What's D? B, C, D, A. E. Vowel. No, not equal. Now, F and B. What's F? Sets of vowel. And what's B we have? The first three natural numbers. Are those equal? No, of course not. Those are natural numbers and these are vowels. Not equal. Moving on. Third question. In each of the following whether A equals to B or not. Okay. So first one, A, B, C, D, D, C, B, A. Yes, these are equal. 4, 8, 12, 16. We have 4, we have 8, we have 16, but we don't have 12. Instead of 12, we have 18. So it is not equal. So the third one is we have 2, 4, 6, 8 and 10. So what's B? Positive even integer where x is less than 10, but we also have 10 here. If it was still 8, this statement would have been true. Or if we has equals to 10, then this statement would have been true, but we have 10 here which should be less than 10, which doesn't include 10. So it is also false, means these two are not equal. Third one is not equal. No, fourth one, A is equals to x is a multiple of 10, right? 10, 15, 20, 25, 30. But the problem is we have 15 and 25 which are not the multiples of 10. These are the multiples of 5. So it is also not equal. Fourth question. State the reason for the following. We have 1, 2, 3 till 10, which is not equals to x where x belongs to a natural number, and 1 where the value of x lies in between 1 and 10. It should not include 1 and 10 because we don't have is equals to sign. It should be greater than 1 and less than 10. But we have 1 here and we have 10 here. So this is true and they are not equal. So what the answer is saying, LHS is greater than 1 and less than 10. But LHS having both 1 and 10. So this statement is true. It is not equal. 2, 4, 6, 8, 10 not equals to 2n plus 1. X belongs to natural number. So if we substitute any values from 0 to 1, 0 to so on in the place of n, we will see if we substitute n equals to 0, 2 into 0 plus 1 which is equals to 1. If n equals to 1, so what is the answer? 2 plus 1, 2 into 1 is 2 plus 1 3 which is equals to 3. If n equals to 2, 2 plus 2 4 plus 1 5. So it is the formula for the odd numbers 1, 3 and 5. But what we have even numbers here 2, 4, 6, 8, 10. So that is why this is not equal. That is what it is saying. 2n plus 1 is the definition of odd numbers as I have explained. 5, 15, 30, 45. Multiples of 15, is it? 15 right, 30 right, 45 right, but 5 is not a multiple of 15. So that is why it is not equal. Now 2, 3, 5, 7, 9. Are these prime numbers? We have 2 prime number, 3 prime number, 5 prime number, 7 prime number. But what about 9? No, 9 is not a prime number because it has multiple as 3 into 3, which makes 9. What are prime numbers? Which have multiples 1 and itself. So this is also true that it is not equal. That is what's the explanation here. X, but 5 doesn't exist in the multiples of 15 as I had said, and 9 is not a prime number. Question. List the subsets of the following. We have B is equals to Q and P. So what could be subset? We have P, Q, P and Q and a null set. These are the subsets, right? X, Y and Z. So what could be the subset? We have value. We have single X, single Y, single Z, which I missed to write. Then X and Y, Y and Z, Z and X, and X, Y, Z, and again null set are the subsets. Now the third one is D, A, B, C, D. We have single A, single B, single C, single D, then A, B, B, C, C, D, D, A. We have B, C, B, D, C, D, D, A, then A, B, C, B, C, D, A, B, D. All the subsets that can be formed with A, B, C, D should be included. Single alphabet as well as containing all of those, as well as null set. Third one, 1, 4, 9 and 16. We have 1, 4, 9, 16, 1 and 4, 1 and 9, 1 and 16, 4 and 9, 4 and 16, right? Then again 1, 4, 9, 1 9 16, 4 9 16, right? 1 4 9, 1 9 16, 4 9 16, and 1 4 16, and 1 4 9 and 16. This should also include a null set as well, right? So here what are we got? 10, 100, 1000. 10 single, 100 single, 1000 single, 10 and 100, 100 and 1000, 10 and 1000, 10, 10, 1000 and 100, along with a null set. These are the subsets that can be made with the numbers. Now the next thing we have is finite set and infinite set. Just by the name itself we can say what does it means. Finite set are the set in which the elements of a set can be countable. If we can express the number of elements present in a set as a whole number, or if we can count the numbers of the elements present in a set, is known as finite set. Example, the students of your school. Yes, you know how many students, you don't know, but your principal does know how many students you have in your school. Now a set B which have value 2, 3, 4 and 5. Can we count 1, 2, 3, 4, right? It is known as finite set. Whereas infinite means which elements we cannot count. Even numbers. Can we count how many even numbers do we have? No, we cannot count. It's infinite. Similarly, divisible by 7. There are so many numbers that are divisible by 7, so we cannot count them. Cardinality of finite set. So what does this mean? It means number of elements that are present in a finite set. A finite set is a countable set. So after counting the number of elements that are present in a finite set is known as cardinality of finite set. The number of elements in a finite set is called cardinality number set, or the cardinality of the set. For example, we have an A set. 1, 2, 3 are the elements. So how many elements we have? Number of elements are 3. It is denoted by n of A. For a finite set, cardinality is a whole number. It is always an whole number. If there are no elements in a set, the cardinality of a null set is always 0. Exercise 2.4. State which of the following sets are empty sets and which are not. The set of lines passing through a given point. Is it an empty set? No, it is not. We can count the lines, right? For example, let us consider this as a point, given point, right? 1 line passing through it, 2 line passing through it, 3 line passing through it, 4 line passing through it, right? We can count how many lines are passing through the point. So it is not an empty set. Next is set of odd natural numbers divisible by 2. Just by the question you can understand. What are odd natural numbers? Those are 1, 3, 5, 7, 9. Can these be divisible by 2? No, of course not. 2 is an even number, so it is an empty set. There are no numbers that can be divisible by 2 which are odd. Natural numbers that is less than 5 and greater than 7. This doesn't make any logic. What's less than 5? 1, 2, 3, 4, 5. And what's greater than 7? 8, 9, 10 and so on. So is there anything in between these? No. So it is an empty set. A common point to any two parallel lines. So what are parallel lines? These are parallel lines. Is there any common point in between them? No, they are not even touching each other, right? Because they are parallel. So it is also an empty set. Set of even prime numbers. Okay, that is not an empty set. We know what are even prime numbers, right? That's 2 is an even prime number. So it is not an empty set. State whether the following are finite or infinite set. The set of months in a year. We know how many months a year have. So it is a finite set. There are 12 months in a year. So it is a finite set. Now next, 1 to 3, so on till 100. It is already giving the finite number from 1 to 100. So it is also a finite set. Next, the set of prime numbers smaller than 99. This thing is also giving us the exact number lesser than 99. It is countable, right? It is also a finite set. Next, the set of letters in English alphabets. We know an English alphabet has 26 letters. It is also a finite set. The set of lines that can be drawn parallel to x-axis. So what's x-axis? Y-axis, x-axis. This is y, this is x. So set of lines. How many lines we can draw? 2, 3, 4, 5, 6, 7. Infinite. We can draw as much as lines we want. So it is an infinite set. Infinite is the answer. Sixth one, the set of numbers which are multiples of 5. There are infinite numbers because there is no n to n number. So multiples also doesn't have an n. Infinite. Next one, set of circles passing through origin. Again, let's draw an origin. This is the origin, right? This point is origin. It's 0, 0. How many circles we can draw? 1, 2, 3, 4, 5. Infinite. So the answer is also infinite. That's it. Thank you.